Okay, for today, it's about slope. What? It was about slope yesterday. Well, it was, but we're just going a little bit more advanced on slope. And how do you find the slope of a curved line? Do you remember there was a little talk of that before we did that thing called the difference quotient? Do you remember that? Okay, this is going to be similar to that. All right, so let's look at a real world problem involving slope. So this is back when Game Boys were a thing, which is quite a while ago. I'm sure they're still around, but what's the big small system now called? A Switch, if I remember right? Or is there something more recent than a Switch? Nintendo Switch is one of them anyway. So anyway, you never heard of a Switch?
Okay. I feel like I definitely have not.
I know my daughter just bought one last year, and she's like an adult now, and they thought it was the best little system they could get that wasn't super expensive. Okay, anyway, Game Boys were pretty popular back in the day, and imagine for a moment that they, of course, had changed it to Portaboy and then wisely put a picture of a Game Boy right next to it. Anyway, do you get that there's the cost, focus please, focus, thank you. There's the cost here, and that is made up of two kinds of things. There's this number which doesn't have a variable, and then there's this kind which does. So are you saying that if we have a cost of 0, as in we make 0 units, 0x, we'd have a cost of 0? No. If you make 0 units, how much do you actually have to pay still? $150. The point is, let's say that you have a factory and you make nothing in your factory that day. You still have to pay for the lights. You still have to pay for your taxes, like to own the property there. You still have expenses. All right, so there's fixed expenses, and then there's expenses that depend on how many units you sell. All right, would you please, in your head, figure out C of 10? So hopefully you just stuck in a 10 in the what? In the C? No, it's C of X. So they told you that X was 10. So then you put a 10 here. And then you said 800 plus 150 is $950. Costs money to run this factory, apparently. Okay, so $950 is your costs. Now, could you also then sell these things and hopefully make money? Yeah. You now have 10 of them that you made. This is a real world thing. Sometimes there are small factories. My daughter actually works in one. She works for Abbott, which they do medical device. And you could be her in just a few years. She was in high school just a few years ago, it seems like. She got her 4-year college degree as an engineer. She went for mechanical engineer. And the mechanicals can do a lot of different things, one of which is you can work on medical devices. So that's what she does. So they have a small manufacturing floor where they'll put out only a few products, but they're super highly tested. They got to make sure that they work really well because it's about medical devices. So you can't just be in the middle of your heart operation and then realize, oh, I guess we made that unit wrong. You know what I mean? Like that'd be a really big deal. So these have to be tested like super carefully, and there's a lot of paperwork too involved in that kind of stuff. Well, anyway, this is a small manufacturing situation. How many Portaboys can be produced for $15,000? Well, where would you put the 15,000? C of X. Yeah, you put the 15,000 here, and it's no longer a 10 there. We don't know how many we're gonna make. And if the 15,000 went here, just trying to show you, we can have some real world context for these questions. Instead of just saying, here's 2 points, find the slope, which is what we did yesterday. Now it's going to be a little more real world where we're going to say, okay, we've got this situation, and let's figure out what the slope is. Well, who cares about a slope when you're manufacturing things? Well, maybe it's the rate that you can produce them. Do you think the boss cares about the rate you can produce things? Oh, yeah. So, as you know, I'm very interested in Tesla as a company. They just had big news last night. They finally made a big profit. This quarterly result just came in, and so their stock went up dramatically last night, or this morning when it opened. Went up $40-some a share because a lot of people are saying, okay, I guess you've proven you can make a profit. So their manufacturing totally depended on getting enough cars out the door. So for a while, they actually put a tent in their parking lot and built extra cars in the tent. It seems like crazy, but they needed to meet these goals of like 5,000 cars a week. And so they made a production line in their parking lot so that they could meet their goal, because they had to prove we can do this. We can actually produce enough cars to do, like actually make money. And then the results just came in of this most recent quarter. They officially made some serious cash for once. How do you make it before you have money? Like, what if you're still building out your plant and you aren't making enough money? How do you survive? Well, they're a public company, so they sold shares. So if you wanted to, you could be a part owner of Tesla by buying some of their shares. Now, I'll keep it really simple. Let's say that they only sold 100 shares. If you bought one, you'd be a 1/100th owner of the company. Of course, they have a lot more shares than that, so you can't just go buy one and become a 1/100th owner of the company. If you have a lot of money, you can buy a lot of shares of Tesla, and you could become a 1/100th owner of the company. And so when they make a lot of money, you make a lot of money. So that's the idea of stocks and how that works. So anyway, they totally care about production just like this. This is like real world problem for them. We have to produce 5,000 units a week. Otherwise, our stock's going to crash in value because we're not going to be making money for the 5th year in a row. And that's going to tick off the investors enough that, you could actually, like, the whole company could implode if we don't get enough production this week. And it got that crazy. Musk said that they were within 2 weeks of going bankrupt. If they had screwed up for 2 weeks, their company would have been out of business. And it didn't, and they're still making it, and they're doing well now, and turned a big corner there over the last, 6 months, it seems like. All right. This one, it's just another real-world example, except this time it's got the price, and it's got X number of systems, and they want you to write an equation. Well, I'm going to give you a hint. In the end, they're giving you 2 points. 220 goes with 20. And can you see the other point that they have there? 190 goes with what? 40. Think about price. Would it make sense if you dropped the price that you would sell more of them? Guarantee you that's true. You go to Target and there's something on the shelf that you want, and you kind of like, should I buy it or not? If it's like 50% off day, you'll be like, oh, yes, I'm going to buy 4 of them. Okay, because the price matters. Would you agree that if iPhones were $25 each, you'd probably have more than one? You'd be like, I'd buy a couple extra because they're on super sale. Not a couple extra. People would be buying thousands of them if they could get them for $25 each, because they might think I could sell them later or whatever. So there's something to do with the price and how many you sell. And Apple's been raising their price a lot until just recently they kind of dropped it a little bit. But there are real world situations just like this where there's companies deciding what we should do with price. Apple had a choice to make in this latest round. Do we up the price again, make it like $1,200 each? They could have. They would have sold phones, but they would have sold less of them. And so they actually decided to drop the prices kind of a little bit on some of their phones, because they felt like, I think it's because they probably looked at their numbers and said, you know what, we're starting to not sell that many phones because they're so expensive. We better not raise the price again. We better take a year off of that. And the grown-ups are making these big decisions in the boardrooms and deciding what they should do on the price. So, okay. I'm going to say, if you have 2 points, you can write the slope. It's pretty easy. Okay. So, let's go to this one. Do you remember a problem in your homework where they said, we have a line, and we have a point over here, and we want to know what are the things that are 4 units away from it? Did you notice that problem? Okay. I want to make sure that you notice that problem. All right, so let's talk about this briefly. This problem that you see drawn here is slightly different. So I'm going to go off to the side, and I want you to do the same thing. And I want you to make the line y equals 2x plus 1 We'll label that right here. Y equals 2x plus 1. And we're going to say the point negative 1, 2, 3, comma 1. Negative 3, comma 1 is this point. Would you agree that you can find a spot that's 4 units away from this? Like there, maybe. Is there some spot that's going to be a distance of 4 away? Yeah, it's got to be some spot. So I'm going to say that it's there, but I don't know exactly where that is. But do you get there to be another spot that would be exactly 4 distance from this? Maybe down there. Don't know exactly where they would be. All right. Since I don't know the coordinates of this point, I get to pick what they are, and I'm going to logically name them x and y. I'm going to go over some distance x. I don't know how far that is. And I'm going to go up some distance y. For some of you, that might have not have been like an obvious thing, but we need to name that point. Why? Because we need the distance to equal, and who has got the Fight Club thing memorized? What's in the first parentheses? X minus the x, and in fact, it doesn't matter which one's which, because when we square it, it won't matter. And then, as you're walking to the fight in the back of the Fight Club, which is the y minus the y, and they're squared up against each other, you would trip over a what? Plus sign, because minus sign would have just laid on the floor, and you could have stepped right over it. I know, kind of a strange example, but it might help make that formula stick in your mind. Because on a test, we aren't obligated to give you all the formulas. Okay, and that's one of the formulas we expect you to know. It's distance formula. It's one of the reasons it's on the top 20. Okay, so now I'm going to go put some things in here. Would you agree that I don't have both points? If I did, I could just put them all in here and I could exactly know the distance right off the bat. But instead, I know the distance. They told us the distance. Do you remember what it was? 4. So we'll put a 4 there. We know one of the x's for sure. It's negative 3. And we know one of the y's for sure. And it's 1. And remember, it doesn't matter whether I put it in the first spot or the second spot, because after I subtract them and square them, it won't matter. Okay. Do you get, though, that I have 2 variables left? Who can fix that problem? Yes?
For the y,
Yep.
put in 2x plus 1.
Exactly. Because y is 2x plus 1. I can replace the y with a 2x plus 1. Why do we care? Because now we got only one variable. Now we can solve it. Now, I don't need you to solve it right this second, but I think you get the idea. And wait a minute. It's got the squareds all over the place. Do you get that that might mean that there's 2 answers? Because when you have an x squared equation, you're going to get 2 answers. And when we're looking for 2 numbers that will make this work. You know what I'm saying? All right. So that's the setup for that problem. And that's just a good real world. Actually, okay, this is not so much real world because we didn't tie it to units like feet and inches and miles and whatever. But it's a good example problem of using the distance formula and being smart about substitution. That moment that only one person in here could think of, nice job, is the key moment where you had to get it down to only one variable. That's going to be the hard part for you. Everybody can write an equation with lots of variables in it. Just put an x or a y or a q every time you don't know something. The hard part is getting it down to only one variable. Okay, moving on. Take a look at this. It's called the average rate of change. Doesn't this look a little bit like that difference quotient that we did before? Okay, but it's a little different. Let's talk about it. This spot right here, if it had been 2, 7, and this spot right here, if it had been 8, 10, do you get I could find the slope between those two things? Because I got 2 points, right? But we don't know what they are, so we named them A and f of A. Does that make sense to you? It's like f of x and x, right? Okay, so they didn't know what they were, so they named them with a variable. Same thing here, b and f of b. And then do you get the f of things? Those are like f of x. Those are like the y's. These are like the y's. And do you get you just subtract the y's over subtract the x's? That's all there is to it. It's just the same thing as before. You're just finding a slope. It's just a more complicated setup. But you still just have the y's subtracted over the x's subtracted. All right, so let's look at one. Here's a real one. This could be a question off a test. If you have this function, y equals 3x to the fourth plus 2, 1 comma 2. I know some of you, before I had just given this lesson, would have said, oh, so you want me to start at the point 1 comma 2. No. That's an interval, and these are just x values. These are x values. That's important because they give you x values, but they didn't give you y values. If I'm going to do this in the context of a and b, do you remember that formula we have up here? It's f of b minus f of a over b minus a. And what are a and b? Well, this is a and this is b. So they said we should do f of b minus f of a. So I'm supposed to do f of 2 minus f of 1 over 2 minus 1. And f of 2 is just the y value when you stick in 2. And this is the y value where you stick in 1. All right, so let's figure out f of 2. Everybody put in a 2. I don't want to just do this whole thing. I want you to do it with me. This one's a little bit of a pain because 2 to the fourth gets big, and then we got to times it by 3. What is 2 to the fourth? 16. Times it by 3. 48. Add 2. 50. So that's 50. What's f of 1? We're going to subtract whatever f of 1 is. That's a heck of a lot easier to do in your head. Stick in a 1 right there. 1 to the fourth is 1. Times 3 is 3. Plus 2 is 5. 50 minus 5. And then the other two values we already know. 2 minus the 1. Now, just for a second, couldn't I have done this way? Where I had 1 comma I don't know what, and I had 2 comma I don't know what. I had the x values, but I didn't have the y values. Just think about it that way. Do you get I could have just figured out what the y values were, and then I had 2 points. Once you have 2 points, you can use that, just like we did yesterday, y minus y1, m x minus x1. That would have absolutely worked too. All we needed here was the slope. We're trying to just find the m, you know. All right. So when they started off with this, the biggest mistake is people think they're giving you 1 comma 2 as a point. They're not. They're giving you 1 comma, and they didn't tell you the y. You have to figure it out. It's f of 1. And then they're giving you 2 for the other x value, and then this will be f of 2. And then you would subtract this minus this over that minus that. F of 2 minus f of 1 over 2 minus 1. Okay. I'll give you another one right now to see if you can. Let's say you had y equals 3x squared plus 7. Would you agree that is a parabola? I'm going to just do a quick little sketch off to the side and say, would you agree it's a stretched parabola that's been moved up 7 and it might look something like that? All right. Let's say I wanted to find the slope between this point and that point. You might be like, but there's a lot of slopes in there, Mr. Server. Sometimes it's like this, sometimes it's like this, sometimes it's like this, sometimes it's like this, sometimes it's super steep like that. You can find the average slope between those two by using that formula we just did. So let's say I say this is between -1 and +2. Then that's like this. You could put parentheses or brackets. I'll put brackets this time just to shake it up. Okay, so now, did I give you 2 points? No, I gave you 2 x values. If you wanted to figure it out as 2 points, you could say I gave you a -1 for this one and a 2 for that one. And then you could figure out their y values. I kind of like that way of doing it. Or, if you don't want to do it with the 2-point system, you can go f of b minus f of a over b minus a. Either way, you're going to have to figure out these y values. So, let's figure out these y values. When you stick in -1 in the equation, f of -1 would be 10. Then I got to figure out f of a. Everybody, figure out f of a yourself. Did it? Uh-oh. Okay. I'm going to keep down in class, so I'm going to pause for just a second. Okay, so we were now going to figure out, we had two things to figure out, f of b and f of a. And I actually realized I put this 10 in the wrong spot. I'm going to erase it. It doesn't go there. It goes there. And f of b, which is this one, which is when 2 goes in. 2 squared is 9, times 3 is 27, plus 7 is 34. Do you guys get 34 there? No? Double checking myself. 2 goes in here. 2 squared is, 2 squared is not 9. 2 squared is 4. 4 times 3 is 12. 12 plus 7 is 19. How about 19? Okay, good. Sorry, I'm blaming my computer. Went down, threw me off. All right, 19 minus 10 over, and then 2 minus -1. Be careful with the negatives. These were the x values, remember? So then this is 19 minus 10, which is 9, over 2 minus -1, which really means 2 plus 1, which is 3. 9 over 3 is 3. What can we say? The average slope over this little part of this parabola, the average slope was 3. So let me ask you. If we'd have just done from -1 to 0, and we'd have just done this little part, doesn't it seem like the average slope should be negative? All right. Would you please figure out the average slope between -1 and 0? So I'm going to rewrite this problem and say from -1 to 0. That's just this little part right here. I would think the average slope will be negative. I'm going to pause for a second while you give that a try. Okay. F of b minus f of a over b minus a. And this time, we're not going to 2. We're just going to 0. So our 2 points, this is not our point anymore. It's down here. F of b, in this case, b is 0. So that's really f of 0 minus f of -1 over b minus a, which is 0 minus -1. So that's f of 0. If I put in a 0, it would be 7 minus f of -1. If I put in a -1, -1 squared is 1 times 3 is 3 plus 7 is 10 over 0 minus -1 means 0 plus 1, which is 1. -3 over 1, which is -3. Do you get that the average slope over this little part right here was -3? Make sense? All right. So this is like the difference quotient, but it is different than the difference quotient. All right. Then sometimes they just say, I want you to make me a line that's parallel to this one. You actually had this in higher algebra. It's a complete review. I don't know why there's a 2/3 on this slide. I don't get that. Because the slope of that thing is not 2/3. Otherwise, it's rising 2 and running 3, but it's definitely not. So I'm going to say what I think this slope is. It looks to me like it goes perfectly through that point right there. And that point right there. It could be off a little bit, but it looks really close to a slope of 2. Can you guys buy that?
Yeah.
Okay. Let's say that the m is equal to 2. Then do you get if I make another equation that has a slope of 2? It'll run parallel to it? Do you remember the deal? What if I need it to be perpendicular, though? If it's parallel, it's going to be 2. If it's perpendicular, it's going to be 1/2 is a good guess, but it's off. Negative 1/2. So it's opposite reciprocal. Okay, so here's a typical question. Here's an equation. I want you to make me an equation that's parallel to this one, but goes through the point 2, 12. It needs to be parallel to this one, and it needs to go through the point 2, 12. Hint, y minus y1, x minus x1, is called point slope. And I just gave you a point, and I told you what slope I wanted by saying parallel. All right, I'm hoping that came back quick. The point goes here and here. The point in this case, the x is 2, y is 12. So it's y minus 12 equals slope. What's the slope? 2. X minus 2. Could you solve it down further? Sure, but you don't have to. That's an equation that goes through that point and has that slope. What 2 little things would I need to, no, 3 little symbols would I need to add to make this be perpendicular to the original one and going through the point 212? In other words, what tiny little change would I need to make? Can I just put 1 over? I'm close. Negative. 1 over negative 2. Or the negative go on top. It wouldn't matter. So those little 3 little things. 1 and over and make it negative. And that would make it perpendicular to that other line. All right. So imagine for a moment this is your question. Y equals negative 2/3 x plus 7. And I want this line to go through the origin and be perpendicular to this. Perp and goes through the origin. This should be like, oh, please give me more questions like that. It's so easy. Perpendicular, flip it and make it opposite, so it's going to be 3 over 2 positive. And then, wait a minute, if it goes through the origin, then its y-intercept is 0, so couldn't I just put plus 0? Yup. If you wanted to write it out as y minus y sub 1 equals m times x minus x sub 1, it's going to work out the same way. Because it's going to go through 0, 0, and have a slope of 3 over 2. When you simplify it down, it'll be back to this. That make sense? Okay. Yay. We're down to real world application of this. They're saying, what if you sell? No, wait. Selling X units. Yep, so it is selling stuff. What if you sell between 0 and 50 units? We can figure out the average rate of change for that situation. Remember, it's f of b minus, what is it again? Minus what? F of a, and then all over b minus a. And what are my, oh, these are my 2 points, the 2 x values of the points. It's 0 comma something and 50 comma something. And then I'd figure out f of 0 and f of 50. Okay, I think you got the idea. Move on. Everybody loves this kind. If you had to graph this, wouldn't it be so much easier if a and b were numbers? What's the first number that you come to where a is less than 0? -1. Now, I have warned you about -1s, but in this case, a slope of -1 isn't particularly like difficult, or one. I know 1 has weird properties, but I think it's okay to put in your -1. And then what's the first thing you come to if b is bigger than 0? +1. And then if you just slap those numbers in, it would be so much easier. Let's ignore this one for now. If I just put in a is -1, that's a -1 here, and b is +1, that's a +1 there, that means it's going to start here at -1, y equals -1x. Oh, wait a minute, it's minus -1, my bad. Minus -1 means +1, so sorry, it's going to be moved up 1. There. And now it's got a slope of -1. Basically, that means it goes like that. Now, how about this? It can only move in one of two directions. It's either going to keep going, the lines are going to keep going up from here, or they're going to go down from there. What do you know about your y-intercept? As b gets bigger and bigger, we picked 1 in the first place. It was the smallest one we could pick. As b gets bigger and bigger, it's the opposite of b. So, like, for instance, if we put in 2 for b, do you get it would have gone down 2? No, wait, opposite, up 2. They're just going to keep going up from there. Next, if they all had the same slope, they'd look kind of like that. Yes?
Wouldn't it be at -1 instead of 1? Because you put in 1 is greater than 0, so it would be -1x.
All right, let me check.
Or -1.
The concern is, and it's a good one, I could have messed that up, so I'm going to make sure I didn't. So I started with a being -1, and I kept a at -1. So I'm keeping my slope at -1 just for now. You okay with that?
Yes.
And then the b, I started with a, what did I tell you the first time? A 1? And then I went up to a 2. And when I put them in here, I thought there was 2 negatives. No, the a was negative. Doggone it. You're right. You're right. It was down 1. Thank you for catching that. Ugh. And I can't record again in the next hour because my other video failed, so this is my last chance. So I have to leave my mistake in here. It starts at -1. You are correct. All right, and then I'm going to keep making the number bigger. 1, 2, 3, 4, 5, etc. And that's going to keep making my y-intercept go to -1, -2, -3, -4, -5. So it keeps going down like this. And to begin with, I'll just keep a -1 slope. Then, since the slopes are also allowed to change to be, as long as the slopes are negative, now the slopes can be anything that's less than 0. So I just can't have a straight up and down slope. The slopes have to be negative. All right. Here's a steeper negative slope for all of these. And it'll be right up until it gets to be vertical, but it can't be vertical. So this would be the extreme end of it. Can't be this, but it'll be close to that. And on the bottom end of it, it could be going through that spot with a really small negative slope. There will never be anything graphed up in here. make sense to you? Okay. All right, 12-minute warning. This is the part where I got to get you to your homework. All right, let's take a look at the homework for today. The first one is this number 44. I want you to just get a big picture of what we're doing here. First of all, it's the x to the third graph, which kind of looks like this. On that graph, we only want to go from -1 to 2. So it's like from there to there, and they're saying, what's the average slope in there? So it looks like it's going to be positive to me. This is not the point -1 comma 2. It's -1 comma something, which we will figure out, f of -1, and it's 2 comma f of 2. And then, to figure this out, I'm going to do f of the 2 minus f of the -1 all over 2 minus 1. All right, I think you should do 44, 45. Page, 46, 49. Next page, 56. I really want to encourage you to do one like this, because if on the test, when you're good at this stuff, there will be context. These questions aren't just going to be, here's a quadratic, find its average slope. It'll be a word problem. So you got to deal with these at home, otherwise you won't be able to deal with them on the test. Then, I don't think we need too many of these. For the ones, you just underline this. See where it says parallel? Circle parallel, or underline it, or highlight it, or something. Because on this page, all you got to do is parallel lines. Let's do 59 and 63. And next page, let's go 65 and 70. And that's perpendicular lines. You find a line perpendicular to this that goes through that point. Perpendicular to that goes through that point. Last 12 minutes here, so I'll give you the rest of the time to work. Have a good day. And that is it. We're well into our 9 more, but I think that's